Next problem in difference of two mean test, right? So the mean height of 50 male students who showed above average participant in college athletics was 68.2 inches with standard deviation of 2.5 inches, while 50 male students who showed no interest in such participation had a mean height of 67.5 inches with standard deviation 2.8 inches. First one, test the hypothesis that the male students who participate in college athletics are taller than other male students. Second one, by how much should be sample size of each of the two groups be increased in order to that the observed difference of 0.7 inches in the mean heights be significant at 5% level of significance. So first they have given mean height of 50 male students, right? So first sample size n1 equal to 50, right? And second, in the second line, while 50 male students who showed no interest in the such participants, so second sample size n2 also 50. Then in the first line, mean height of 50 male students who participated in the athletics, right? Their mean height is 68.2 inches. So x1 bar they have given 68.2 inches, and their standard deviation, with that standard deviation 2.5, s1 equal to 2.5, right? And in the second line, they are not interested in athletic, right? So their mean height is 67.5, that is x2 bars equal to 67.5. their standard deviation s2 is equal to 2.8, right? So defining hypothesis, there is no significant difference between the participant and non-participant, right? So there is no significant difference in the height. Alternate hypothesis, we are taking the two-tail test, mu1 not equal to mu2. There is a significant difference between the heights, so we are using two-tail. Let the level of significance is 5% level, right? Test statistics z is equal to x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. Substituting these values, 68.2 minus 67.5 by root of 2.5 square by 50 plus 2.8 square by 50. So we will get 1.3185. So calculated value of z is equal to 1.3185. So but the tabulated value at 5% level is 1.96. So tabulated value calculated value 1.3185 is less than tabulated value 1.96. Therefore H0 is accepted. That means there is no significant difference in the heights, right? That is the conclusion. Right, next second question, let the sample size of each group be n, right? To find n, right, we need a size of sample, right? Given that the difference between the mean heights is 0.7, significance at 5% level, that is what they have given. So that is difference between mean height means x1 bar minus x2 bar is equal to 0.7 at 5% level. We know at 5% level z value is 1.96. Two-tail test we are using, right? Note that. We know that test statistics z is equal to modulus x1 minus x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. So z is equal to, that value is 1.96. So difference is they are given 0.7, right? S1 they have given 2.5 square, but n1 equal to n2 is equal to n in the second case, right? Let first line, let the sample size of each group be n, that means n1 equal to n2 is equal to n, right? That is what we are substituting here, 2.5 square by n plus 2.8 by 8 square by n, which is equal to 1.96. so that is equal to, so we are taking left side denominator to right side and right side 1.96 to the left side. So root of 2.5 square by n plus 2.8 square by n, which is equal to 0.7 by 1.96, that is equal to 0.373571. Squaring both sides, Otherwise you can easily calculate the value. Take n is common, take it outside, so root n, 1 by root n, then 2.5 square plus 2.8 square, square root is 3.754, right? Therefore root n, which is equal to 3.754 by 0.3571, that is 10.512. Now squaring both sides, you will get n is equal to 10.512 square, so approximately 111, that is 110.5. so sample size is 111. Hence the sample size of each two groups is increased by at least, already you are having 50, right? So difference is 111 minus 50, that is 61, right? So next method, defining hypothesis h naught is equal to mu1 mu2, right? No difference in the mean height. Alternate hypothesis, let it be greater than, that is athletic people height is greater than non-athletic people, right? Mu1 is greater than mu2, right? And so we are using right tail, right? So calculated value same, right, as it is as per the previous case. So mod z is equal to 1.3185, but tabulated value will change because we are using right tail, so right tail value is 1.645. now conclusion is, again calculated value is less than tabulated value in this case also, therefore h naught is accepted, there is no significant difference, right? Second one, let the sample size of each group, that is n1 equal to n2 is equal to n. To find n, we know at a 5% level z is equal to 1.645, right tail test, right? So we are using the same idea, so put 1.645 instead of 1.96 and simplify, so you will get 1 by root n into 3.754 is equal to 0.4255, therefore n, which is equal to approximately 78, that is the difference, right? In that previous case you are having 111, now you are having n is 78, so difference, the increase is 78 minus 50, that is equal to 28. In the previous case 61, right? Note that. Thanks.